On page 3 in the notes today, and as I said, these are complex fractions, and as you're looking at these, they look awful. It's just too many fractions, too many dividing bars. The steps that we have written here, they're okay, but I actually kind of want to show you more of a visual way of what we're going to be doing to tackle these problems. So in all of these, you will see that we have kind of a top part of the fraction. Evaluating that is going to be step 1. Then we have a bottom part of the large fraction. That's going to be step 2. And then step 3, we're going to handle that middle division bar, and that is going to be where we divide by the reciprocal. Sorry, multiply by the reciprocal. Or keep, change, flip. The goal is one fraction. Instead of the many that we start with. So simplify the top first, the bottom second, and then keep, change, flip to handle the big division. So let's go ahead and see if we can break this problem up into its parts. So I would say that this is the top of this problem. Top. This is the bottom. And then this dividing bar will be what we handle last. So we're going to go ahead and start with the top of this fraction. Now, if I told you to simplify the top, what operation do we have going on? We've got subtraction, and I really have two fractions. If you're looking at that going, 5's not really a fraction. We can put it over 1. And then we need to find a common denominator. So comparing 2 to 1, what would my common denominator be? 2. So if you want, you can write that the LCM of the top would be 2. So we're going to multiply this fraction by 2 over 2. So that will give me x over 2 minus 10 over 2. And that simplifies to be what? X minus 10 all over 2. So we took those two fractions and we turned it into one fraction. So that is now the top. Now we move to the bottom. If I look at the bottom, I have addition. And we have two fractions. We've got 6 over 1 and 3 over x. What would you say that the LCM, or rather the LCD is what we were using yesterday, least common denominator. What would you say the LCD of the bottom is? X. So I'm going to multiply this one by x over x to get 6x over x plus 3 over x. And adding those tops together, add the tops, we get 6x plus 3 over x. So there's the top fraction, there's the bottom fraction. It still looks awful, but instead of having 1, 2, 3, 4, 5 fraction components, we now only have 1, 2, 3 fraction components. So we've successfully evaluated the top and the bottom. Our last step then is to change this big dividing bar to be multiplying by the reciprocal. So we're going to keep the top. We're going to change the division to multiplication. And we're going to reciprocalize the bottom to be x over 6x plus 3. And I'm going to go ahead and rewrite that a little bit more nicely down below. So we have x minus 10 over 2 times x over 6x plus 3. So now this is going back to what we did on the first day of this unit. So we changed the dividing by the bottom fraction to be multiplying by the reciprocal of the bottom fraction. So can I cancel out that negative 10 with that 2? No, why? Because trap that binomial. I can't take out parts from it. 6x plus 3, you know, that's a binomial too. But can I factor anything in this problem? We can take out a GCF of 3. So that leaves me with 2x plus 1. Now, unfortunately, taking out the GCF doesn't lead to any additional simplifying, but it does make it look better with our final answer. We go straight across, and we're going to put the monomial x in front, x and x minus 10. And then on the bottom, we're going to mush the 2 times the 3 together to give us 6. And then 2x plus 1. And that is our final answer. And if you're like, is that really better than what we started with? It is, because we only have one fraction bar. Instead of having fractions on fractions on fractions, we now have it as one fraction. Yes?
Why don't you, like, distribute it like that? Like, why wouldn't the final answer be, like, 12?
You could distribute, but for simplifying, factored form is always best. So at the end of yesterday, when we were adding the fractions together, we always tried to factor. With multiplying and dividing, we always left it in factored form. So just to ensure that we have checked for any additional simplifying, you can just leave it in factored form. Good question. More questions? Alrighty, let's take a look at this one. I'm gonna go ahead and box this off. All right, so on this problem, let's figure out what we are looking at. We've got the top 2 fractions that we're going to need to add together. We've got these bottom 2 fractions that we're going to need to add together. And then our final step will be the division in between the top and the bottom. Now this one, we take it up a slight notch because finding the LCD of the top and the bottom is a little bit more complicated. As I look at just the first 2 fractions, what do you want to do with x squared minus 9? We want to factor it. X squared minus 9 is the same as x plus 3 and x minus 3. So that's that denominator in factored form. That's my other denominator in factored form. So my LCD of the top, the greatest amount of x plus 3's that I have, is 1 x plus 3. The greatest amount of x minus 3's I have in one term is 1 x minus 3. So there's my LCD. So what am I going to need to do to get this denominator to look like the LCD? Nothing. We've already got it. But this one is going to need what for its creative form of 1? X plus 3 over x plus 3. Trap, 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 trap. So we are going to distribute the 2 to the x and the 2 to the 3, and then we are going to add those together. So I'll have 4 plus 2x plus 6 all over x minus 3, x plus 3. I skipped a little bit of work there. Is everybody okay with what happened? So this fraction stayed the same. That's where the 4 came from. And then I'm adding it to the distributed top 2x plus 6 of the second fraction. So there's my new top. And we will simplify it, but I want to make sure we space out our room correctly. So we're going to go ahead and look at the bottom of this fraction. What is the LCD of the bottom going to be? trap, 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 trap. It's actually going to be the same as the top. So our LCD is x plus 3 and x minus 3 for both. When the LCDs are the same, it's actually going to lead to some super fun simplifying. So let's go ahead and write our creative forms of 1 for both of those fractions. This will be multiplied by x minus 3 over x minus 3. And this one, x plus 3 over x plus 3. So when I distribute, we get x minus 3 from the first fraction. When I distribute over here, add that stuff together, we get x plus 3 from the second fraction. And then that is all over the x minus 3 and x plus 3. So common denominator on the top to add those fractions together. Common denominator on the bottom to add those fractions together. Before we keep, change, flip, let's go ahead and simplify. 2x will stay 2x. 4 plus 6 will give me 10. And that's all over x minus 3. X plus 3. Then on the bottom, what's x plus x? 2x. And negative 3 plus positive 3 cancels. So I just have 2x over x minus 3, x plus 3. So there's the bottom stuff. There's the top stuff. Anything jumping out at you about the top part of the top fraction? GCF. So we're going to go ahead and while we're at it, take a 2 out of both of those, which will leave me with x plus 5. So I've got this top fraction divided by this bottom fraction. This is where we keep the top and change the bottom to be multiplied by the reciprocal. So let's go ahead and show that step. So the top stays the same. So 2x plus 5 all over x minus 3, x plus 3. And then instead of dividing by the bottom, we're going to change it to be multiplying by the reciprocal. So x minus 3 and x plus 3 will go on the top. So we're flipping that fraction all over 2x. Now that this is multiplying, we can slide these fractions together and cross simplify. Is there anything that we will be able to cross off? Perfect. X plus 3, x plus 3, x minus 3, x minus 3. And there's one more thing. The 2. So because this is a monomial, this is 2 times x, there's no addition or subtraction, I can take that 2 out as a factor with that other 2. So folks, our final answer on this one will be just the x plus 5 on the top and just the x on the bottom. But wait, can I take out that x with that x? No! We cannot take parts out of binomials. So x plus 5 over x. Hooray! Questions? Yes?
So lost.
So lost, that's why we're just going to keep doing them. So where did I lose you? All of it?
Everywhere.
Everywhere. Okay, so first we start by figuring out what the top of the fraction is and the bottom of the fraction. So we find kind of the largest vinculum. That's what the name of the dividing line is. We find our largest one, and then the stuff above it, top, stuff below it is the bottom. Handling the top, this is like the problems we did yesterday, where we need to add them together by finding the LCD. So we factored, found the LCD, and then used the creative forms of 1 to turn that into one fraction. We simplified that and factored it. So then I have one simplified fraction on the top. Then we did the same thing on the bottom. Found the LCD, which happened to be the same, multiplied by creative forms of 1 to get the same denominator so we could add those fractions together. And that gave me a simplified version of the bottom. Then once I have that top simplified fraction divided by that bottom simplified fraction, we can keep, change, flip. So let's go ahead and take it a little bit more slowly on this next one. So what's our top fraction? Who's our top fraction? So here, the top fraction is just this. This is my large vinculum that separates the top from the bottom. And that's the bottom pair. So we're going to start by simplifying the top first. There's no adding or subtracting of fractions on the top. I already just have one fraction here. But what's your gut telling you we should do with that denominator? We should probably try to factor it. So let's go ahead and write that as 6x over, let's see, x plus 2 and x plus 2. So that was my top fraction. And all we did to it was factor the denominator. I didn't have to find a common denominator because I didn't have to add that to any other fraction. There was just one fraction on the top. How are we doing with that so far? So now for the bottom fraction. Here I have two fractions. I'm going to need to add those together. Do we currently have a common denominator? We do. We've got x plus 2 and x plus 2. So I already have a common denominator. So what are we going to do with those tops? Add them. So on the bottom, we get 11 over x plus 2. So now we simplified the top, it's in factored form. We simplified the bottom, it is in factored form. Our last step is to handle the division. This is currently division. We want to keep the top, change the division to multiplication, and flip the bottom. So we're going to keep the top fraction as 6x over x plus 2, x plus 2. We're going to change the division to multiplication. Now, when we flip the bottom fraction, what's on top? X plus 2 all over 11. So now that it's multiplication, we can join these together and multiply and multiply. And we can cross simplify. Is there anything I can get rid of?
Yeah.
What? Only one of those x plus 2's. Anything else? No. Nope. So our final answer, what we're left with is a 6x on the top. And on the bottom, we have x plus 2 and 11. It's considered proper form to put that monomial first. So 11 and x plus 2. And that's our final answer. And I think we'd agree that that definitely looks better than what we started with. Smaller items, simplified, less fractions. We've got one vinculum on that problem. Okay, folks, questions on that one? That one was a little bit less work because we didn't have to do anything operation-wise with the top, and we already had that common denominator on the bottom. Go ahead and take a look at this one. Who's our top fraction? A plus B over 4. There's the top. Is there anything I can do to simplify or factor that? No. When do we go to lunch?
2 minutes.
Thank you, Nathan.
11:10, which is 2 minutes. All right, so well, I'm glad someone knows the bell schedule. What about the bottom? Can I do anything to that? Can I simplify that?
No.
Can we factor it?
Oh, wait.
Yes. No.
Why not?
Maybe so.
There is no sum of squares, so that's as simplified as that one's going to go. So I'm going to trap that a squared plus b squared. So then I have top divided by the bottom. So we're going to keep the top, a plus b, trap, over 4. We're going to change the division to be multiplication. Pew, pew, pew. We're going to flip the bottom, 4 over a squared plus b squared, which we cannot factor. There is no sum of squares. Can I simplify this?
Yeah.
What are we going to do?
It's so weird.
Hmm?
No.
Cancel out the 4s, and that's all we can do. It's very tempting to try to take out an A or a B from this, but that is one factor. That is one factor. That is as simplified as that expression will go.